All right, we're going to be working today with solving inequalities by addition and subtraction, and we'll do an introduction as well as a couple examples. They're really solved exactly like you solve equations, okay? However, there's one important caveat that we'll get to in one of our next videos when we need to multiply or divide. But for now, if we're just dealing with addition or subtraction, you solve them exactly the same as you solve equations. Your answer is almost always going to be an inequality. In fact, I think always, guaranteed always, will be an inequality. If you're solving an inequality, your answer will be an inequality. Many times you'll need to graph your solution on a number line. And you can also check, in terms of checking, you can check the boundary answer, and you can also check an extreme answer. So let me give an example for that. Let's say we get an answer that x is less than 3. All right, what I would like to check here, what I would be tempted to check here, is I would actually plug in 3 and see if it barely does not work, because that should be less than 3, right? And then I also like to check an extreme answer like -50, for example. And that should work. That should check out as long as we did the problem correctly. And then usually we express our answer with a variable on the left. That is not a mandatory rule, I don't think, but I think it makes more sense. And let me show you what I mean. If we have x is less than 3 versus 3 is greater than x, to me, x is less than 3 makes a little more intuitive sense. We know that x just needs to be smaller than 3. And that makes more intuitive sense than saying 3 has to be larger than x. So usually the variable is on the left, though not a hard and fast rule. So let's do a couple examples here. Okay, addition and subtraction here, and what we will do on this first one, x plus 5 is greater than or equal to 3. As always, we need to work towards isolating for x, and we can subtract 5 from both sides. Everything else is just like when we're solving equations. X is greater than or equal to -2 is my solution. So we can plug in a boundary answer, and I'm not going to do this formal check on every single one, just in the interest of time, but for this one I'll show you we can plug in our boundary answer, which should work, and we can plug in an extreme answer of 100. And the extreme answer really makes sure we have the inequality sign pointing in the right direction. Is -2 plus 5 greater than or equal to 3? So is 3 greater than or equal to 3? It is. 3 is equal to 3, so 3 checks out. And our extreme answer checks out as well. 105 is greater than 3. Okay, so both of those check out. It looks like we did it correctly. For this next one, 4 is less than x minus 3, and this one is a little bit curious or interesting, I guess, just because the x, the variable, is on the right-hand side. So I'm going to still add 3 to both sides here, and these guys cancel. We have an x remaining on the right and a 7 over here, and that is a legitimate final answer, although I think it's better form to reverse, to swap the order with an x and a 7, and then this inequality sign would swap as well. X has to be greater than 7, and that would be my correct final answer. Let me show you a boundary check here. Again, I won't do the full check. The full formal check is 4 less than 7 minus 3. Is 4 less than 4? Well, it's not. It doesn't check out, and it shouldn't, because we want x to be strictly greater than 7. We don't want x to be equal to 7 here. And so plugging in 7, for our check, it should just barely not work out. So it looks like we did the problem correctly, and our solution is x is greater than 7. Let's look at the second example here, and looks like we have a couple interesting things going on. You probably noticed the fractions first, and I noticed the subtraction of x first as well. And what I'm going to try to avoid right now for this video is having to multiply or divide by a -1 to get rid of that negative in front of the x. Okay, there's a little bit of complexity involved with that we'll get to in a little bit. So what I'm actually going to do here is I am going to add x to both sides. So basically what I'm telling you right now is that negatives can be tricky when we're dealing with inequalities. So let's get rid of those negatives. 2/3 is greater than 3/4 plus x. And now we can subtract 3/4 from both sides. And let's see what that ends up as. 2/3 minus 3/4, we'll have to get some common denominators here, is greater than x. So we've isolated for x, but we have a little bit of simplifying to do. Quick reminder, whenever you're getting common denominators, you can always multiply any individual piece in the equation by any special version of 1, and you don't have to do it to both sides. You can just do it to individual little pieces. So I'm going to do something like that here. I get an 8/12 minus a 9/12 is greater than x. Okay, so we have our common denominators. Looks like we have a -1/12 is greater than x. And I'm going to flip that whole thing around, including the inequality symbol. And this is just telling me that x has to be smaller than -1/12. Okay. In this case, what I'm going to do is a quick mental check. I'm going to plug in an extreme number. And the reason I'm doing that is because I did some switching of my inequality sign. I flipped some orders. I just want to check to make sure I have my inequality in the right direction. So let's plug in like -100, for example. Okay, so back up at the top is 2/3 minus -100, so plus 100, greater than 3/4. It is. It checks out. Okay, so I'm pretty confident that we did the question correctly. And that's a good place to stop right there.